Using cooperative groups and pairs enables students to engage in peer learning, especially when experimenting with manipulatives. Students at various levels are able to ask questions or explain answers to each other in a peer-to-peer tone. Listen to the way cooperative pairs think through the problems in this lesson on fraction computation.
Tom Arnston begins this lesson by reviewing the key concepts taught in the first fractions lesson.
We've talked about that a denominator is the number in the bottom of a fraction that tells us how many equal pieces you have to put together to make up a whole. We've talked about that the numerator are how many pieces you have there that are part of that whole. We have added fractions together, like 6/8 plus 1/8 equals 7/8.
He then introduces the students to fraction problems involving different denominators.
I'd like for you to read for me.
2/10 plus 1/2.
Very good. 2/10 plus 1/2. This is a fraction sentence, but there's something that's different here.
Before discussing the answers with his class, Tom has his students pair up to work through the problems.
Only we have 1/10. 1/2 plus 1 equals 5/10. So 1/2 is 2/10.
He then chooses one student to answer.
Allison, I want you to tell me, what is different with this sentence?
It's different denominators.
Very good. She found out that there are different denominators here. Well done.
Once the idea that fractions can have different denominators is established, Tom shows his class how they can substitute a fraction for its equivalent.
Dylan, what did you and your partner discuss?
7/10 equal the half is like 5.
The half is what?
The half is like 5.
5 what?
5 of the 10th.
So let me take the half out. And here are the tenths that he used in place of that.
This concept can be difficult for some students to grasp. Tom recognizes this and gives individual attention to support his students' needs.
I had 5/8 actually.
You had 5/8 there?
Yeah.
Well, what does the denominator show you, though?
Yeah, are you fine today?
How many pieces make up a what?
6.
Good, so the denominator here is 6. It takes 6 pieces to make a whole. So each one of these pieces is 1/6. And how many 1/6 pieces do you have here?
5.
5. So it's 5/6.
Finally, Tom has his students demonstrate their understanding of equivalent fractions, both symbolically as well as visually.
How many 12ths?
3.
3. So did you do this? Did you find out that 3 of these is the same as 1/4?
Mm-hmm.
Okay. And what is 3/12 plus 3/12?
6/12.
6/12. Very good. How many of you out there did what they did? Can you show me by raising your hand?